Hello everyone. Today in this video we'll be discussing three more sets of reactions of carboxylic acids. Now the fifth set of reactions that we'll be discussing in this video is sort of a combined reaction. In the examination sometimes you are given an unknown compound and generally the examiner tells you that the compound can be either it can be any organic compound. So first you have to identify which type of compound it is. Does it have an OH group or does it not? If it has an OH group, three types of compounds come to mind: alcohols, carboxylic acids, and phenols. Now, one thing to understand is that phenols are something that we do not study in AS, and you may not have heard this word before, but it is a class of compounds that we'll be studying in detail the chemistry of in A2. So for now, you only need to know it to the extent that our syllabus concerns it, and that is to the limit of only this set of reaction. Okay, now in front of you I have drawn a flow chart. The flow chart may be a bit confusing, but if you just study through it you will see some things. X is an unknown compound. It can be any organic compound. First of all, to tell the difference whether it contains the OH group or not, because you can see that all three of these possibilities contain the OH group. So first we have to identify whether it has the OH group or not. That possibility will be given by adding metal. Sodium metal will be added. If we add sodium metal and we get fizzing, why will fizzing happen? Fizzing will happen because the OH group always reacts with sodium metal to form hydrogen gas. That is the reaction that we've done. When alcohols react with sodium metal, they serve hydrogen gas as a byproduct. The same case with carboxylic acids and the same case with phenols. You have to accept the fact that phenols also give off hydrogen gas. Now, if fizzing doesn't happen, it's quite clear that OH group is not present. But what if the OH group is present? If fizzing does occur? If fizzing occurs, you will then add NaOH. We very well know that NaOH does not react with alcohols. We have already discussed this in a previous video due to its chemistry. But if the reaction occurs, if water and a colorless salt is formed, if a colorless solution is formed, then that means it can be a carboxylic acid or a phenol. You have to accept the fact that a phenol can react with an alkali. It is an accepted fact. Okay, you have not studied this in detail and you will not study it in detail. Now the next set, to set apart the difference between carboxylic acids and phenols, you will add sodium carbonate. If fizzing occurs, why will fizzing occur? Because of the effervescence of carbon dioxide gas. If fizzing occurs, we very well know it is a carboxylic acid. If fizzing does not occur, it is a phenol. So this is the difference. This is a distinguishing chemical reaction that is often asked in the exam. To make things easier, I have put this in a table form, so you can clearly see the flowchart has been put in a table form. A carboxylic acid will react with all three reagents, an alcohol will only react with the first reagent of a sodium metal, and a phenol will react with all of them except sodium carbonate. The conclusion that we get from this entire set of experimentational reactions that we just carried out, we can see that if we want to identify whether an unknown compound is a carboxylic acid or not, we should just directly react the carboxylic acid with sodium carbonate or any carbonate for that matter, and we would be able to tell that it can only be a carboxylic acid, it cannot be any other organic compound. So this is one thing to keep in mind. The next set of reactions that we'll be covering is esterification. Esterification, as the name suggests, is when an alcohol and a carboxylic acid react to form an ester and water. So let's just look through this example reaction that I have given. I have given the reaction between ethanoic acid and methanol. and that is forming this ester and water. Now the reagents are quite important. They are concentrated H2SO4 and heat under reflux. You may notice that this is a reversible reaction. Why exactly it is reversible, we will come to in a later video. Now you can see that an ester is being formed. How exactly this is formed? Let us see that. Now if you look at the structure of ethanoic acid, the carbon is bonded to a double bond oxygen and it is bonded to a single bond OH group. Now the OH group from here and the H from here will be taken away and this will form H2O, and the rest will be bonded together and that will form this. You can clearly see from where we removed the OH and the H of the alcohol, we added them both together and they formed a bond like this, and this forms the ester bond, and we can clearly see the ester linkage of C double bond O, C single bond O. Now below over here we'll be doing naming of esters. The first one has been done for you. This is the acid part of ethanoic acid and this is the alcohol part. Naming of esters is sort of taken in a crisscross technique. The alcohol part comes first and the acid part comes later. The alcohol part will always have the suffix of YL and the acid part will always have the suffix of OH. So methanol and ethanoic acid will give the name methyl ethanoate. Okay, I've given some more examples over here to serve as a purpose of example. Now let's see. This is the acid part, simply because the C double bond O is bonded to this. That is why it's the acid part. And this is the alcohol part. So it's a 1 carbon acid. So it is obviously methanoic acid. And it is a 2 carbon alcohol. So it is ethanol. So the name should be ethyl methanoate, if this is understood. Now moving on to the third example. Over here I have not set it in a structural formula way, rather I've just written it in a straight chain. So this is the ester linkage. The carbon is connected to these hydrocarbon chains. So this is the acid part and this is the alcohol part. There are how many carbons in this acid chain? There are 5 carbons. So it is pentanoic acid, and there are 2 carbons in the alcohol chain. So it is ethanol. So the name should be ethyl pentanoate, if that's clear. So one thing to understand is that esters are formed when an carboxylic acid and an alcohol are chemically combined, and their naming should be known, and you should also know some properties about them. Some of them being that they are sweet smelling compounds and they form a layer on top of the water. So meaning that they are less dense. Esters are less dense than water. Next, we will be looking into the next set of reactions, which are the reactions of the OH group of the carboxylic acids. We will be dealing with 2 reactants, PCl5 and SOCl2. SOCl2 is also called thionyl chloride. You don't need to know the chemistry of it. All you need to know is that these two, each of them separately, combine with carboxylic acids to give 3 separate products. Now let's look into it. The first set of reactions is that of a carboxylic acid and PCl5. Now PCl5 is a covalent compound. Keep that in mind. You don't need to know the reaction mechanism of this reaction. All you need to know is that one of the products will always be an acyl chloride. We discussed acyl chlorides as an acid derivative, if you keep in mind, in a previous video. and one of the products will be HCl. This acyl chloride is a 2-carbon acyl chloride. Its name is ethanoyl chloride. You don't need to know details about this. All you need to know is the name and how it is formed. And a third product is formed, which is PCl3O. You don't need to know the name and you don't need to know its nature or state. All you need to know is this reaction simply. Keep in mind that if an observation is asked for this specific reaction, you should know that HCl is gaseous. It is hydrogen chloride gas, and hydrogen chloride gas are released in the form of white fumes. So if an observation is asked, you will just mention that white fumes are released. Now the next set of reactions are that of ethanoic acid or any carboxylic acid for that matter with SOCl2. Again, the one bystanding product is ethanoyl chloride and the other product is HCl gas as we discussed. The third product, however, varies in this case and you get SO2, sulfur dioxide gas. Now in this case, there are two products that are gaseous. You should know that this is colorless and this is white fumes. So if an observation is asked, you will say that a colorless gas and white fumes are released. That is it for this set of reaction of the OH group. And that is it for this video also. Thank you.